Hello everyone, welcome to this session. Our chapter is compounds of metals. So in our previous video, we saw the introduction to this, the compounds of metals. We saw the various these kinds of compounds of metals. We started discussing about the metal oxides. Now today let's see how you can prepare these metal oxides. So the preparation of metal oxides. The metal oxides can be prepared by mainly two main methods. The first one is the direct method. So this is the first method whereby it involves the heating the metals directly in air, while the second method is the one that is in direct method, whereby it involves such methods like heating carbonates and hydrogen carbonates of certain metals in air and reacting certain metals with certain acids. So these are just the two methods of preparing the metal oxides. Now let's discuss the first method, that is the preparation of the metal oxides by the direct combination or just by direct method. Now in this kind of a method, oxides they can be prepared by direct combination of metals with oxygen or simply burning uh, the metals in air. So it involves heating a metal in air. And now when some metals are burnt in air, they react with oxygen of the air to form the metal oxides. However, this kind of a method is not intensively used because some metals they just tend to form a protective layer of an oxide on the surface of the metal and prevent further attack by the oxygen or further uh, uh, the reaction of the uh, metal with the oxygen. So the best example of such kind of metals is the aluminum, which when heated in air, it forms a protective layer of the aluminum trioxide on the surface of a metal, which then prevents the further attack or further reaction by oxygen. The table below, it simply shows the products formed when certain metals are burnt in air. So this is a table preparation of metal oxides by direct combination or direct method. Here is the metals and how it reacts with the oxygen and the product obtained after the reaction. The first one is the barium. It burns with the green flame. So this is how it reacts with air, and the product is the white solid, that is the barium 2 oxide. Then there is calcium that burns with the black red flame, which leads to the product that is the white solid, that is the calcium oxide. Then there is sodium, which burns with the yellow flame, and the product is the white solid, that is the sodium oxide. And then there is also potassium, that which in terms of reaction with air, it burns with the purple flame, while the product is the white solid, that is the potassium oxide. Then there's the magnesium that burns with the white flame, and the product is the white solid, that is the magnesium oxide. Then there is also iron that burns with the yellow sparks, whereby the product is the blue black solid, that is the iron 2 oxide. And last but not least, the copper that does not burn, just turns black. So the product is the black solid, that is the copper 2 oxide. So all these are just the metals which, when directly burnt with air, that's the oxygen, results the various products which are just the metal oxides. Let's move on to the second method, that is the preparation of metal oxides by the indirect method. Now, in this method, it involves the thermal decomposition of salts, whereby when some salts are heated, they decompose into oxides and the other products as well. Now, if the anion part of the salt heated contains some oxygen, a portion of this oxygen may remain bonded to the central metal atom, so that you have to note it. Now, however, this kind of a method is limited only to those compounds of metals below sodium in the electrochemical series. We've discussed this electrochemical series in our previous videos or sessions. For instance, potassium oxide or sodium oxide cannot be prepared by action of heat on the carbonates, but the ones that are below these two are the ones that can be prepared by this action of heat. Uh, The thermal decomposition of some metals is as shown by the following equations. Take an example, this copper carbonate is as to the copper oxide plus oxygen gas. So this is the first example of the thermal decomposition of the copper carbonate. Then the other example, calcium carbonate decomposes to calcium oxide plus carbon dioxide gas. And then zinc carbonate, it decomposes to zinc oxide plus carbon dioxide gas. Hydroxides are also there. They also behave in a similar manner, whereby when hydroxides of metals below the sodium in the electrochemical series are heated, they decompose into respective oxides, giving off the water in the form of steam. Example, as you can see here, calcium hydroxide, when it decomposes, leads to the calcium oxide plus this water, whereby in form of steam or gas. Then there's also magnesium oxide hydroxide, which when decomposes leads to the magnesium oxide plus water in form of gas. The oxides can also be prepared by heating some nitrates and sulfates. As you can see here, lead nitrate, when it decomposes, leads to the lead oxide plus the uh, nitrate plus oxygen gas. Then there's the copper nitrate. When it decomposes, it leads to the copper oxide plus the nitrate plus oxygen gas. So these are just examples of the oxides that are prepared by the heating of some nitrates and sulfates. We've seen the examples of on these nitrates. Now the nitrates of silver and the mercury are not suitable for the preparation of oxygen by the thermal decomposition because they decompose to metals directly when heated. They do not decompose to metal oxides. The bond between oxygen and the metal atom is not strong enough to withstand the thermal energy. As you can see here, this is the silver nitrate. When it decomposes, you can see it release this metal and plus the nitrate plus the oxygen gas. So that's all I have for this video. Hope it's clear, everyone. Thank you for listening. I will discuss the two main methods of preparing the oxygen, the metal oxides. We've said that there is the direct method and the indirect method. I hope it's clear, and thank you.